All right, so using Cramer's rule to solve three equations in three unknowns. All right, so in this example, you have the coefficient matrix to the right, and A1, A11, A21, A31, those are your x coefficient. A12, A22, A32 are your y coefficients, and A13, A23, A33 are your z coefficients. All right, and similar to when we did it for two equations in two unknowns, we're going to replace, it's the determinant of the coefficient matrix, replacing the coefficients of x with b1, b2, b3, dividing by the determinant of the coefficient matrix. For y, replacing the coefficients of y by b1, b2, b3, dividing by the determinant of the coefficient matrix. And z3 would be, for z, replacing the coefficient of z by b1, b2, b3, dividing by the determinant of the coefficient matrix. All right, with that in mind, let's do 31. All right, so for 31, first thing, the coefficient matrix. The coefficient matrix, we have 1 to 1, 2, -1, 2, 3, 1, 1. That's the coefficient matrix. If we wanted to, we could have done this. X, Y, and Z. And this is equal to 1, 2, 1. So this is just representing our system of three equations in three unknowns as a matrix equation. Later on, we'll look at how to use matrices to solve this. We're not doing that now. Right now, what we're doing is Cramer's rule. So we're going to need the determinant of the coefficient matrix. So let's erase this. We're going to need the determinant of the coefficient matrix. So this would be 1 times the determinant of -1, 2, 1, 1, minus 2 times the determinant of 2, 1, 1, 1, plus 3 times the determinant of 2, 1, -1, 2. All right, so this is going to be 1, -1, -2, -2, 2, -1, plus 3, 4, -1. So this is -3, -2, plus 15. So the determinant of the coefficient matrix appears to be 10. So x would be equal to, according to Cramer's rule, x would be equal to, replacing the x coefficient with 1, 2, 1, 2, -1, 2, 3, 1, 1. Divide by the determinant of the coefficient matrix. And the coefficient matrix would be 1, 2, 1, 2, minus 1, 2, 3, 1, 1. If you look carefully, you'll see that the numerator and the denominator is the same. So if you divide something by itself, the answer is 1. Y would be equal to, you're going to replace the y coefficients with 1, 2, 1. So it's 1, 2, 1, 1, 2, 1, 3, 1, 1. Earlier we said something. I hope you are all listening. This is 10. What we said earlier is that if two columns are two rows, if two columns are two rows of a matrix are the same, or if two columns are two rows of a square matrix are the same, we say the determinant is going to be equal to 0. So this is actually This is actually 0 divided by 10, which is 0. So y is 0. Let's go for z. And I think z is going to be the same issue. 1, 2, 1. Put in x, the x values. Sorry, the y coefficients. But you're going to replace 3, 1, 1 with 1, 2, 1. So again, what we have is that 2 of the rows, and this is divided by 10, 2 of the columns are identical. Therefore, the determinant of the numerator is going to be 0. The denominator is 10. Z is actually 0. So in this, x is equal to 1. Y is equal to 0. And z is equal to 0. So example 32 says solve these simultaneous equation. We need the determinant of the coefficient matrix. Coefficient matrix is 2, 4, 1, 1 minus 3, 2, 3, 1, 1. The determinant is 2. The determinant of minus 3, 1, 2, 1, minus 1, the determinant of 4, 1, 1, 1, plus 3 times the determinant of 4, 1, 1, 1. This is 2 minus 3 minus 2 minus 1, 4 minus 1 plus 3. Will that look exactly the same? So let me see if that's the case. Back here. So this should be minus 3 here. So we have a little correction to make. All right, you block the 3, 4, minus 3 here, 2. So this is 8 minus 3. This is 2 times minus 5 minus 1 times 3 plus 8 times 11. This looks like minus 10 minus 3 plus 88. How much does that work out to be? 75? Yeah, 75. So, by Cramer's rule, x is equal to the determinant of 1, 7, 5, 1 minus 3, 2, 3, 1, 1 over the determinant of the coefficient matrix, which we just work out to be 75. So this would be 1, determinant of minus 3, 1, 2, 1. Oh, all right. Somebody just point out an error. That, which, thank God we caught it early. It should be 3 times 11, which is plus 33. And so this would not be, well, this would not be 75. It would be what? 17? Looks like 17. And so this is 17 here. So this becomes 1, the determinant of minus 3, 2, 1, 1. Somebody saying, Nathan is saying it's not 3, it's 20. So we made a mistake somewhere else. Yes, it is 20. All right. Simple thing to correct. Maybe after a while, tiredness get to you. 20. All right, so resuming, this is 1 times the determinant of minus 3, 2, 1, 1, minus 1 times the determinant of 7, 5, 1, 1. Then plus 3 times the determinant of 7, 5, minus 3, 2. And this is all over 20. So this becomes 1 minus 3 minus 2 minus 1, 7 minus 5 plus 3, 14 plus minus 15, which is plus 15. All over 20. This becomes minus 5 minus 2. What's that? 29 times 3. That's what, 57? All right. It is 29 times 3 is 57. All right, so this becomes what, 50 over 20? You're right. So this is 87, which is 80 over 20. X is 4. Y, by Cramer's rule, let's replace the Y coefficients with 175, 2, 4, 1, 1, 7, 5, 3, 1, 1, and this is over 20. So this becomes equal to 2, 7, 5, 1, 1, minus 1, 4, 1, 1, 1, plus 3, 4, 1, 5, all over 20. 2, 7 minus 5, 1, 4 minus 1, 3, 20 minus 7. Sorry, yes, all over 20. This is 4 minus 3 plus 39. Or 20. So this is 40 over 20, which is 2. So y is 2. Z, I'll call it a day. Z, we're going to replace the Z coefficients with 175, 2, 4, 1, 1 minus 3, 2. And 175. And this is over 20. So this becomes equal to 2 minus 3, 2, 7, 5. Plus, sorry, minus 1, 4, 1, 7, 5. Plus 1, 4, 1, minus 3, 2. Over 20. This is 2 minus 15 minus 14 minus 1, 20 minus 7 plus 1, 8 plus 3, 20. 2 minus 29, 13, 11, 20. This is 58. 20. So this is minus 60. Is it minus 60? Yes. Over 20, which is minus 3. So z is minus 3, y is 2, and x is 4 are the solutions of the equations.